I don't think you could have gotten away with one modality if you didn't have all this culture. So probably, and that's why humans have all these things that David's talking about, because we're the product of evolution, and LLMs are a product of culture. So, yeah, so I would stress that much more than just put it at the end as something that people might not get. That would be my key topic, the key sentence.
Jitendra.
I'm Lenore Blum from Carnegie Mellon.
Jitendra, who we all wish was here, always says they're not foundation models. They're super structure models, right? they're the models that are like the stuff way up at the top of the Chrysler Building. They're not actually the foundations.
So just to comment briefly on this issue of modalities and the potential role for theory here. I mean, I think it's absolutely fascinating that we can get successes across different modalities. The thing that I would love to see, I guess, both theory and data on is what counts as success, and how can we compare cross-modally the kinds of success that we see relative to the amount of data, and to what extent are we seeing modality effects versus kind of distribution effects? Like, talking about the physical world is, both different in its bit rate and different in the ways we talk than seeing the physical world, and separating those things out feels really kind of important to me and tricky to do. Incredible to be inspired by the performance on kind of real world benchmarks and robotic performance, but tricky to do without kind of some theoretical analysis in a smaller scale ecosystem.
I guess just picking up on that last point, is language special? And I think, there were a couple of talks today taking different perspectives on that question, but special either in the kind of uninteresting sense of there's just a lot more of it and we can train current models on it, or whether there are particular pieces of information that are accessible more easily when presented as language rather than in some of these other kinds of modalities. Or conversely, and I think coming back to something that Alison was saying before, are there things that we think should be possible to get out of embodiment and analogies to the physical world that for whatever reason we don't have the right learning algorithms for now?
Point of information, I'll repeat my apology for not being here for all the talks. I was here for your talk, and I guess I'm curious if we have a working definition of language, especially in the context of large language model. In the old days, I might have said you could have a language model on pixels. And I might even refer to our LVM as a large language model, even though there's no text involved. But I feel like I'm in a minority on that. But I'm curious what does language mean in the sense that you asked the question? I can turn the question back to the chair.
Well, I think, people should feel free to answer that either way, right? But there's language literally in the sense of, the kind of thing that we speak out loud and that we write down when we're producing things that we, call text. And there's just whatever is getting slurped up into the training sets for these models right now. And, I think they're one really... Yeah.
Does a language model require language?
Oh, I mean, I think that battle has already been lost already, but maybe an interesting facet of that is that there are a bunch of capabilities that we think of as being sort of core to language, the ability to do variable binding, long range reference, things like that really only seem to show up inside these models once you've also trained them on lots and lots and lots of code and not just on text data. And so there are, and I think this again gets at the point of, what is the generalization from, maze solving to backtracking search and proofs of mathematical theorems or whatever look like, that there are, I think, concrete, what feel like really language, in the first sense capabilities that at least in these models come from training on text data that's not necessarily language data.
I think it's worth pointing out language itself you could think of as I mean, it is a device for compressing very large amounts of perceptual and motor information in a way that makes it easily accessible to other people. And that means that that information, that's the whole point about language, is that it's in a different format, and a format that's designed especially to be transmissible. So it's a bit odd to treat it as if it's like another modality. It's not really another modality. It's a way of extracting all the information from those modalities in a way that compresses it and makes it easy to transfer. And that means that you'd sort of expect that what it would do would be a summary of all the other kinds of information that you were getting from other sources, and that you could go back and forth from that information to other sources.
I guess I sort of wanted to plus one that because, you know, when we do in my lab, we did some little experiments on cultural transmission, like, you know, what language do people actually use when they teach each other stuff? And there are particular pieces of language that people use to convey generalizations. Generics are one, certain quantifiers are another, and those do not correspond to any single piece of perception. They're these like incredibly efficient packages for like conveying useful things that you can extract. And so I think, like, you know, we should separate the amazing fact that from in terms of modeling, turns out we don't need any other specialized tricks from what we actually get from the data, which I think is, like, you know, different from an equal dosage of data of language than it would be from, you know, vision, or like, you know, I guess like Mike is going to complain at me about not saying what dosage is, and then Philip is going to complain about the fact that the representations converge, but I still think there's like fundamental differences in what you get.
No, I was going to plus one this, since we're doing the psychologist plus 1 hour. I know, I mean, I do think it's really important when we're thinking about learning from language, that we think about language as this conditional distribution, which is conditioned on like people wanting to say stuff also about the world or some counterfactual relation to it. And so it is a kind of a very funny fact that when you average across all that conditioning information that you don't know on the internet about what world they were seeing and who they were trying to talk to, you can pick up something interesting about the general kind of compression of world knowledge that people want. It's really totally fascinating and fundamentally surprising that then the same tricks work on picking up on that as work on picking up on those regularities in images.
I was going to take us in a different direction, maybe. I have two questions. They're kind of intertwined. First one, which is kind of related to a paper that just came out, is do you think that language is necessary for reasoning? That's question number one. Like, do we need to think in language in order to be intelligent at all? And question number two is, do you think that it's sufficient for reasoning? Because okay, I'll tell you what I think. I think that it's not, that there's a lot of stuff that we get from, for example, vision or other sensory modalities that inform our reasoning, and that language can't cover everything. But I wonder what you guys think about either of these sides of the question.
I have struck feelings, but I mean, I guess, you know, I don't think language is necessary for reasoning. I think you could imagine reasoning in images. It turns out to be a lot harder just to get it to work. We tried and failed in my lab to do like visual chain of thought. And then recently there was, you know, 1 or maybe like 20 papers that did this. I think there are reasons that it is harder to do broad coverage reasoning in vision. And it has to do with what I said a second ago, that like language has these primitive, you know, pieces for generalization that it's very hard to capture with an image. You can get there partway by using visual depiction, which is kind of like, you know, like when we draw diagrams where we are communicating using graphical depictions in a language-like way. And so that's like somewhere halfway in between. But I also think that like language is sufficient. It may not be sufficient to reason about all of the things that an agent that has vision would want to reason about. But if you are an agent who has language only as your input, or you basically whatever modality you have, it's sufficient to reason in that, and language is a sufficient basis for the things that language models can reason about. Not saying that very clearly.
Okay, maybe I didn't ask. Of course, it's sufficient because it's complete, but it doesn't. Of course, it's sufficient because it's like a complete system, but does it actually cover everything that we care about? And to your first point, we don't have to reason in pixels, right? When we think about the visual world or other modalities, I mean, we could be working in higher level or mid-level representation. So for example, if you're navigating, you don't really need language, right? You kind of need to have some idea of the map. You kind of need to have some idea of where you are. If you're thinking about behavior prediction, you don't need necessarily language or pixels. You kind of need to work in some mid-level representation of like, okay, there's a person, Allison is going to do this, Trevor's going to do that. So that's the kind of thing that I'm kind of asking.
I don't know about the second one. We should hand it over to vision people. But for the first one, I do think language is complete because language is designed so that we can convey to each other all of the things that we, wish to talk about. And so I think, it sometimes takes a lot of words, but I think kind of like the design of language is such that we can communicate the things that we, pretty much ever wish to communicate. Sometimes it's a lot easier to draw pictures, but I think, you could talk about it if you needed to. Obviously, this is my spicy biased take.
Just one quick comment on that as well. So if we're thinking about a normative claim about humans, humans are representationally very creative. That's a major signature. And so for any given representational challenge, even if by default they do it in one particular method, there are people who have developed other methods of reasoning. Just to give you one example of this, pretty much every human kid learns mathematics via a linguistic footholds. They learn to count by learning the linguistic count list, and then they use that scaffolding to learn about the semantics of numbers, and then they go to the symbols and so forth. But there are all these really fascinating and creative ways that people circumvent language and still reason numerically around the world, including various different finger and body count systems, the use of an abacus, the use of mental pictures of an abacus to do fast and accurate arithmetic, and many other tricks. So that representational creativity is usually kind of concentrated in key domains of expertise, but I think it's a general feature of our psychology that we should keep in mind when we think about like kind of what works in a modality and what doesn't. It's like, well, what do we practice? What's generic, but also what can we create for a particular situation?
By the way, we had a talk in the first workshop from Pietro Pelona about learning the number sense from manipulation. So you should look it up. That's very cool. So no language, just like manipulating objects on a table.
I mean, we should probably get Lucy to contribute. We have Lucy and Amanda. Sorry, I don't mean to put you on the spot, but just making the point that it seems a little odd to think that none of the other intelligent species on Earth are doing anything that's approaching reasoning, right? That seems a little weird. And if they're navigating and doing all the other kinds of things that they can do, there's some kind of format that's enabling them to do that. And I think it's really an interesting question, Noah. So I'm going to infuriate Jack by saying something about neuroscience. But if you think about, which is always infuriating, Jack's always a good thing to do. If you think about like hippocampal replay, I hadn't thought about that before, but you can make an argument that hippocampal replay is really doing for spatial things what your reasoning system is doing for in a linguistic case. And I'm sure the comparative people would have lots of other examples of being offline but going through the representations.
I actually think it is very much, although Jack will tell us more, but and I think it transcends this question about like what modality do you is necessary or sufficient, but like the weird thing about that sequential density estimator viewpoint is like sequential density estimators are just like prediction machines that you can roll out into the future, right? And so like what those theorems say is that like, if you can have these like steps that you can roll out into the future, you can use them to sew together local experiential expertise. And that's kind of what I want to call reasoning. It's like a little bit circular to say, like, I defined reasoning as the thing that my theory says you can use to do reasoning.
But doesn't like the hippocampal replay is actually a lot like that.
I think it's a lot like that. I mean,
That's been pretty much their argument. So yeah, you're not far off. But I'm not a hippocampus guy, just so you know.
by the way, I wanted to ask a question to like, I don't know who, but earlier when everybody was talking about how like all the data converge and, you know, all the modalities are the same, it made me kind of wonder, do we now know what it's like to be a bat? It's just the same as everything else with more squeaking?
Okay, that was actually a good segue to my question. Also, this is going to be extra spicy to ask with Philip Masilla in the audience, so that's very fun. I think that a lot of the times when I've heard people talk about this, they don't mention that like this idea is pretty similar to my very limited philosophical understanding of what Ludwig Wittgenstein said about like language being a projection of all that exists into like some sort of subspace, right? Like in some ways that almost seems like more of a parallel than like the Plato's cave allegory. But also he famously became a hater of that same theory, right? He's like, oh yeah, language is super contextual. Someone can say water to refer to like a body of water in the real world, or they could say it because like they were in the desert and they're very thirsty and they're asking for water. And that second one, I'm sort of struggling to like see how to place that second one. Is that like a fundamental, is saying water to like requests for water, like a fundamental truth of the world that like language converges to? Will images also converge to that same approach? I think that like the view mentioned earlier where it's like there are some sort of like amodal shared general representations and then like specialist ones. Maybe like there's a lot of overlap between the specialist ones, but like it doesn't seem to be exactly the same thing, right? And so this brings us all the way back to Jacob's talk, where like language models seem to represent the world in a specific way. And he gave those examples of like different models of the solar system. Each one seems to be useful for like different types of questions, as he said, right? And so I was sort of thinking like, is that like do we want a big model to be this sort of like Platonic representation of the world, or should it be like more agentic and have representations that are specifically useful for a given task, right? Because even among cultures, like maybe we don't have a word for a table with 3 cups of water on it, but some sort of like restaurant waiter robot or whatever would want a concept for that and assign a word to it, right? So does that contradict like Platonic idealness because of like agentic behavior and reasoning and all that, or what?
So there's a lot there, but I would say that when I met Noah first, he was early Wittgenstein and I was late Wittgenstein. I don't know where we are now on that, but you know, basically what that kind of conversation did, at least in my kind of personal intellectual history, was lead to kind of thinking through models of communication in context, and the idea that the distributions that you observe are conditioned on context and communicative motivations. And so the trick for world model learning is that you're learning, you need to deconvolve what somebody's trying to tell you about the world and the world. And in some contexts, maybe alchemy game is a good one for that. Like those two things are really not that, the communicative demands are not actually so difficult. In other cases, that can be extremely difficult. And, maybe that's a question for Jacob, how, when that trick works best and when it doesn't.
Yeah, I mean, I don't know that we have a great answer to that question right now. And, again, I think it's the sort of thing that, like you were saying before, what you have to do to be a good language model is to look at the, string in which you're doing next token prediction, impute the posterior over possible situations that gave rise to that text, and then guess what somebody was going to write next coming there. And I can imagine that, on one hand, that's an amazing way to, learn to solve all kinds of interesting hard reasoning problems, and, especially learn representations not just of the physical world, but human culture and all those kinds of things. But that on the other hand, in many cases, that inference problem is just too hard to pack into a single pass through your language model. Or on the other hand, that what's going to give you at the end then is not something that's necessarily steerable in the way that you want it to be steerable, because nowhere in the pre-training data did you ever actually see, here is a complete specification of the situation in which I want you to act and the agent that I want you to act like in this situation. Now produce a bunch of text. And, I think what we have right now, and then that thing that where you sort of completely specify behavior, and then just ask for a model to execute it, is what, all these sort of chatbot interfaces to AIs are trying to be right now. And I don't think we really know whether it works or how well it works, or whether there are other things that we need to be doing at training time, so that you can turn off or more precisely control all that imputation of the missing context, to the extent that it's happening. It's not totally visible to us.
Just picking up on the Wittgenstein reference, was it the first line of his first book was, the world is something like, the world is everything which is the case, which he meant, the world basically consists of facts. Now, I don't think Wittgenstein thought of facts as linguistic, so he didn't say it's a world of language, but there's obviously a pretty close correspondence between facts and sentences. In principle, any fact can at least be encoded in a sentence. Some language, maybe even a natural language, if your natural language is expansive enough. And that observation that every fact can actually be encoded in language kind of connects to one of these very general themes we've been talking about today, which is what it seems kind of surprising to many people that language has been so successful. Training these language models just on predicting language has turned out to lead to systems which are competent in things like reasoning, maybe even visual tasks, and so on. And there's a reaction, oh my God, who knew that just language could do that? Now, from a certain perspective, from this Wittgensteinian perspective, maybe it shouldn't be so surprising. If every fact in the world can be encoded in language, then sure, give a system enough language and ought to at least have the basis to do everything. So I'm interested in the thoughts of you guys on the panel about just exactly what is the really surprising thing about the fact that training on language gets you to do all these things. Is it that it's not just that you can get to these things in principle from some kind of language or from enough claims in natural language? Is it that you can actually get there from the actual bits of language that people have produced and put on the internet? Is it some more specific claim about prediction? Anyway, I'm interested in all your thoughts about that.
Yeah, I guess just to react right away, I think that last point about the distinction between, what you can encode in language and what's actually showing up in the training set is really, really important. And, maybe the first thing is not that surprising. And for the second thing, again, I don't think we really know how much it's that there was more that was written down in the training set than we expected, and how much it's that even just to, sort of fill in the missing bits in the data that's there, you have to, and you can learn to assign values to all the latent variables. And, this feels something where certainly I feel like I just haven't wrapped my head around what the training data for a GPT-3 or a GPT-4 actually looks like and how much is in there. And, maybe there are people who have better intuition for that than me, but I think that's, you can't really answer that second question until you really understand what's in the training data.
Am I allowed to say that? I was never surprised. Not by any. Just rewrite history.
Did you invest in the? Did you invest in it?
Yeah. Seeing as how I was young Wittgenstein, I should not have been surprised by it. No, the whole thing was surprising that it worked at all. Right.
I mean, you're just to sort of, since it's the end of the day and we could give a slightly spicy take, right? I think for me, the thing that was most surprising, I'm surprised by everything, but was just how wrong we were in fixating on producing grammatical sentences as a major challenge. Like, it seems like, right, like there's kind of a bit of a reckoning that we have to do as cognitive scientists. You spend 50 years saying like, no possible way. This is the last threshold. And then it turns out you don't need 500 billion words to get grammatical sentences. You need like 100 million. 500 billion gets you like crazy reasoning phenomena and multilingual support and all that other good stuff. But the relative ease with which abstractions that we thought were somehow unknowable are popping out of the data in ways that support behaviors that we thought were unlearnable. And you can make the same argument with respect to theory of mind. The empirical grounds are a little more complicated there, but I think it holds in terms of the emergence of the abstractions. But certainly whatever is supporting like doing good subject verb agreement, like, wow.
Yeah, but on the other hand, in retrospect, it's interesting that coding and grammar turn out to be the things that are really sort of stunning, right? And when you ask people, what do you actually use it for in a useful way? People say, oh, I use it to, write letters and I use it to code. And the coding is really the one that impresses everybody. And in retrospect, syntax and code are both examples where you're pulling out internal sequential structure, but you're not doing this piece about referring to the world or interacting with the.
Well, I mean, code is very grounded, no?
Is it?
I mean, it's grounded in your world, not in my world. But it's grounded in, I take code, I compile it, I evaluate it, I get things running in the. Why?
Well, here's the contrast case that I wanted to ask Trevor about, which is, you're thinking about your spicy point, Ellen. I've been thinking a lot about piano playing. So think about piano playing as an activity. It's very cultural. It requires tremendous expertise. It seems to involve understanding very complicated causal relationships between your actions and outcomes that they would not normally, you couldn't have worked out in the evolutionary context, to speak to Jacob's point. But I don't think you encode it in language, right? Nobody ever managed to teach somebody else to play the piano by talking to them. And that speaks to this robotics point. And that's why I'm a bit skeptical that what will actually happen is that we'll be able to generalize.
We don't, or we couldn't?
We couldn't, is what I'm claiming.
I mean, we certainly don't. But just like the Borges thing, like, right? We talk about that.
Could you?
Which is incredible.
But it is sort of striking that we don't, right? And that it's important. It's important that we don't, and not just, playing baseball and this long list of sort of skilled actions that seem very human, that seem to be, that seem to require a lot of cognitive work. They're certainly not something that you can do simply.
But I mean, I don't know that we use language to teach everyone even language tasks. And some language tasks you probably have to learn by exploring and rewarding yourself. So I think,
What do you think?
I think this is working. I think learning how to make an argument or learning how to describe something. I'm not sure that I'm just told how to do it. I think I learn how to generate communicative symbol sequences. So it doesn't surprise me that some things I will learn behaviorally and some things I will learn through communicative instruction.
No, do you think you can teach someone to play baseball? Sorry.
I think you can teach someone to do some like really physical, simple activity. Piano is more advanced, so let's maybe go simpler. Just play baseball, throw a ball for that. You will write a book, and I've never played baseball, and you will give it to me, and I'll know how to pitch perfectly.
Do you mean a human or one of Trevor's crazy robot, cyborg things?
I mean, his robot probably has a much higher chance than me to succeed at the end, but.
I think things like that are really hard for humans, but I think it might end up being for uninteresting reasons. Oh, sorry.
Yeah. Well, I mean, it could be like, obviously, this is not how humans actually, behave, but
if we're talking about the space of like intelligent creatures, like, you know, humans have particular hangups like short memory and like, you know, just things that are kind of quirky about us. And that may not apply in general. And I like would not be at all surprised if there's like some other intelligence that, you know, maybe comes from the like, what did you call them? VLRMs, vision, robot, language, cyborg things. That like, you know, yeah, you could write down a book of like, you know, I'm going to give you a lot more details about how to play baseball, put it all in context, and then it'll play baseball.
Well, but I think, you know, that maybe the sort of central tension here is that sometimes we're asking this question about people and sometimes we're asking this question about LMs. And, you know, maybe a general question for the panel is like, what are the limits of our ability to answer these kinds of questions about human intelligence and the role that, say, language plays in human intelligence or other kinds of supervision play by answering analogous questions about computational models of the kind that we have today.
So I have a kind of a, I guess, naive question, but so it seems to me just amazing how well LLMs do at where basically they're just trying to predict the next word and just that, like somehow just predicting the next word and you get all this great stuff. Whereas intuitively, as a human, it feels like I use language because I'm trying to communicate. I'm trying to maybe collaborate. I'm trying to find some efficient way of, you know, getting what I want. Or, you know, maybe I want more food. Maybe I want to let's get together and, you know, scavenge for food together or some kind of purpose. But maybe that's, you know, like I would think that would be somehow intrinsic that in language, this idea that, yeah, the things you want to say are the things that will help you, you know, efficiently interact and kind of get the things you want. But with the fact that there are other people you're talking to is somehow important. But maybe it's not. I don't know. Yeah. So I guess I just wonder your thoughts. I think, Allison, I think you were telling me that I shouldn't be thinking this way. I think when we were just talking before.
It's just you shouldn't be thinking that way about babies when they start to talk. It's very natural to sort of think, oh, and babies really are just talking because they want the grown-ups around them to give them food or whatever. And that's just not. The babies are doing this as much for cognitive purposes as the adults are. That was just the point. But I do think there's a bit of a difference between the idea that in principle, this gets back to something that someone else was saying. In principle, you could have language that could encode anything. And then again, the fact that these systems are learning from actual stuff that's been put on the internet, those seem like really different points. So your point, Noah, was, well, in principle, you could write down everything that you need to do baseball or whatever, but that seems different from the fact that they're learning from those particular pieces of information. Just another, as a psychologist, as the developmental psychologist, one of the things that's interesting about the grammar is that we actually knew that babies, 7-month-olds, are doing great next token prediction. That's one of the things that they're actually best at. And we've known that for 25 years, 30 years now, because of the work that Jenny Safran and Dick Aslan did. And all of us developmentalists were sort of saying, huh, weird, like they can do amazing next token prediction. Maybe it's got something to do with language learning, but nah, language learning is really hard. You can't, you know, that you need an innate language grammar mechanism, because it couldn't just be the fact that they're spending all their time immediately as soon as you give them a next token prediction task, focusing on solving the next token prediction task, even when it's nonsense syllables. I don't know, Mike, if you, as the person who's actually the expert about this.
I mean, I came into grad school saying, so I had read those papers by Jenny Safran and thought, oh, all we need to do is just this thing, whatever this thing is, and we're going to get all of language. And, you know, at the time that totally didn't work. And everybody convinced me, and I convinced myself that was a fundamental limitation. And so I was like, oh yeah, okay, it's impossible to discover these abstractions. And obviously that was wrong.
So what's the next impossible thing that's going to be done by something trivial?
Okay, I'm going to take Andrew and then Jack, and then we're done. Okay.
Hi. So I wanted to follow up on the last question I guess one thing I think about a lot is the fact that there are sort of things that we figured out that just sort of happen to make everything work better. Like the fact that we're using Atom Optimizer now instead of SGD makes the models train so much faster and much more data efficiently than it would have otherwise. And so I guess my question is, how should we think about that and possibly the other dumb things we're doing that we haven't realized yet in the context of thinking about the results, like the data gaps between these models and humans, or the things that the models do and don't do? How should we think about the fact that maybe there's just something simple that we haven't figured out yet, but in 2 years we will, that might make a very fundamental difference in the kinds of things these models are succeeding at or failing at a given amount of data that they consume?
So the logic for me of cognitive modeling has always been fundamentally a scientific logic of proof of concept, right? That's the role that models have played in cognitive science throughout its history, is you can do a thing. And the positive proof of concept has a different inferential logic associated with it than a negative one, right? So the fact that some, and this comes back to Jacob's question about the role of theory. But so fundamentally, I mean, I think that's exactly right. It could turn out that the sample efficiency gaps are like something we don't know about optimization or attention or whatever. And that would be a contingent fact. And so the kind of failures wouldn't be fundamental. Something fundamental to make inferences around. Whereas if it turned out, in the counterfactual word dino v2 or whatever, learned just as fast from the same data as humans and reproduced the baby data, we'd be like, well, it looks like the distribution in this data is sufficient. So I think, it's not perfect, but that's the logic that I would follow in making those inferences.
I guess this is also like me saying, generally we use cognitive modeling as an existential claim, and we can't make universal claims, and that's what theory is for. But I actually think we're at a moment when we can start to do more theory that makes universal claims. Like, I showed you very briefly a theorem that said like any sequential density estimator that's risk minimizing, blah, blah, blah. And that critically does not depend on any of those details that we just happen to find. There are similar theorems about, in context learning, which I think kind of go a long ways towards explaining inductive learning, which have been a big mystery. And so I'm hopeful that while on the engineering side, we will continue to have kind of like sporadic accidental miracles, that on the theory side, we can actually make more coherent, consistent progress.
I mean, another piece of that, and I guess the way I was interpreting that question, I think there is still just a huge amount of room also for architectural differences and improvements at that level of a kind that it seems like people have really kind of stopped working on to have consequences, right? And I think there was, at least for a long time, the conventional wisdom was, okay, well, we had RNNs and we had transformers, and really the only difference between a transformer and an RNN and an RNN is that transformers are easier to train, and something that's really come out in the last couple of years, like especially in the context of in-context learning, is that there are very specific inductive biases that you get from these attentional architectures that seem to be pretty important for a variety of these, specific oh wow phenomena that showed up in GPT-2, GPT-3, things like that. So certainly, I don't think we're at the end of that story either, and that there is room to expect that gap to close, or at least to narrow, in purely architectural terms.
Jack?
This is a really fascinating day. I just want to point out, I never thought of Trevor's obvious point that we're training all these intelligences backwards. I'm going to have to go home and think about that for a while. Noah pointed out several times today that humans are memory limited. I definitely know humans are memory limited because I only have one memory neuron in my whole brain. Most of my life consists of confabulating what happened rather than actually remembering it. And I actually think that's pretty common in humans. If I just ask you what you did this afternoon, you probably don't actually remember it. You essentially reconstruct it from the local context and your knowledge of the world. And it seems like these LLMs don't really do that kind of thing very much. And I wonder, so that got me starting to think about what would what causes that in us and why they don't have it. And I think the thing is they don't really have any kind of notion of episodic memory unless you kind of build in locally. Like for this session, I want you to pretend you're, David Bowie, and then you can get some David Bowie answers. But tomorrow they won't remember. But obviously that's going to change. We're all going to have our own personalized little LLMs are going to kind of follow us around and be our own little managers. And how do you think that's going to change the way they perform and what they can do?
I mean, I think on the point about confabulation, there's actually plenty of confabulation in current models right now, right? That they're
for humans, it's a feature.
Yeah, no, but I mean, I think that, broader point about how much of reasoning and memory and all that is getting, even sort of setting aside the episodic thing, how much of what models sort of know about the world is getting pulled directly out of some parameter matrix where it's been stored somewhere versus reconstructed on the fly, is a super interesting question. And I think very closely related to like all the star stuff that Noah was talking about. And just when all of the work of figuring out what to say next and what's true that supports what you're going to say next, when that's actually happening.
Just from a cognitive science perspective, when I'm talking about trying to quantify the amount of data to do a thing and then the kind of task performance on a thing, relatively more atomic tasks in cognitive science have generally been more successful with that strategy. So we get a lot of, vision and language stuff. As you look at goal-directed planning that requires memory and reasoning and so forth, all bolted together, the training data and the evaluation data are both much sparser and harder to work with, just from a cognitive science perspective. Now, I'm in no way an expert on this, but people are going around bolting those components onto LLMs in various ways all the time now. Noah and I taught this class, and we read a paper by June Park, which is quite lovely, where he bolts on, sort of a memory store and some goal-based planning stuff, and then puts a bunch of LLMs in a town, and they throw a Valentine's Day party and so forth. It's really quite astonishing. So, this is going to happen. And the question I think we have to ask is like, how do we actually compare, beyond comparing that to our intuitive cognitive psychology of like, yeah, they should have episodic memory. How do we actually compare that to what people do? And that, I think that's unsolved for me. How many Valentine's days do you get?
Okay, I think this is a good segue for a party that's happening right outside. So there is a reception. You're welcome to come out. There's food, there's drinks, and you can continue this discussion between yourselves and the speakers right out there.